All right, everyone, welcome over to another version of Algebra Journal. This time we're going to start looking at factoring. Now, this is the very first time that we've done factoring, and if you listen to me in class, I probably told you that this is the actual, one of the really big things that happens in algebra is factoring. In my head, the two biggest concepts in Algebra 1 is the slope and graphing a line, and then factoring a quadratic equation or a quadratic expression. So we're going to start looking at this, and I'm going to give you two different options for factoring these really simple ones. Now, these are the most simple ones that we can do. And first way is going to be with algebra tiles. And to do the algebra tiles, we're going to look at this equation right here, which is x squared plus 5x plus 6. So I want to take you through this entire thing. So I'm not going to look at the stuff that I see there in the bottom. And I'm going to go to my factoring frame. Now here in the algebra tiles, notice that what we have is 1 x squared. We have 1, 2, 3, 4, 5 x bars. So these are just in the shape of x. And we have 6 of the unit squares. So this is x squared plus 5x plus 6. And we got to get this to look like a rectangle somewhere in this region right here. So normally what we do is we take this x squared and we just kind of shove it in the corner. So we're going to do that. The next thing we're going to do is we're going to put some of these bars up over here. I don't know how many. Let's do a good number of them. Yeah, let's do this many bars. I'm going to show you that first. And then we're going to take some of the bars and we're going to rotate them. And we're going to put them under the blue x square. And then in this space right here, we're going to put all of our unit tiles. So let's put the unit tiles in there. Let's pick them up and put them in. Let's see what we can do. 1, 2, 3, 4. And then we've got these two guys down over here. So they don't really fit in. So I can't really make a rectangle yet. Now if this happens, your next option is to take one of these, probably the last one, rotate it, put it underneath, and try to line these up again so that it works. Okay, so this looks like it's going to create a rectangle, which is what we want to do. We want to be able to make a rectangle. So looking at this down the side here, what was here before? Well, there's an x and then 2 units. So on the side here is x plus 2. Now across the top, there's an x and then 3 unit tiles. So this over here is x plus 3. So when you put it together, what we get is x plus 2 multiplied by x plus 3 is equal to the x squared, that's this one over here, plus this is 3x and 2x, so 5x, plus this 6 over here. So this right here, this thing that we just came up with, this is our factored polynomial. X squared plus 5x plus 6 is the same thing as x plus 2 multiplied by x plus 3. So we have solved this. We've factored the polynomial x squared plus 5x plus 6. And it's factored, quote unquote, because we've taken it and we've made it into two things being multiplied against each other. So the trinomial is the binomial x plus 2 times the binomial x plus 4. Now we're going to try this again with x squared minus 3x plus 2. So let's go ahead and get to our algebra tiles. Here's our tiles in order, and let's just try putting them in. We'll take that one and we'll put that one there. We'll put this one here. We'll put this one here. And I feel like I'm going to need at least one of them. So let's rotate this tile, put it at the bottom here. And look at that. It makes a rectangle really nicely. So this worked. It looks like we're almost factored. So let's see what this is. We know that an x goes on the side, but we also should know that this should be a negative 1. Now, I know it's going to be a negative 1 because the bar next to it is negative. So notice that the red bar matches over here with the red rectangle. So if you see that pattern, this needs to be the red. So that's x minus 1. There's also the same pattern up over here. That minus 1 there. This minus 1 over here. And the side of the x square, well, that is just a regular x. So factored, it looks like this. We've got this tile, these two tiles together. That is x minus 1. That's x minus 1. And then up over here, these tiles, well, these tiles are x minus 2. I'm having a hard time grabbing them right now. Oop. There we go. X minus 2, x minus 1. So the equation that we have here then is x minus 1, which is this, multiplied by x minus 2, which is this, is equal to all of this, which was x squared minus 3x plus 2. That is our factored form. So, seems kind of easy, but putting these tiles together all the time, that really is kind of a lot of work. So maybe there's a way that we can kind of shortcut this. So we're going to try and shortcut this again. And we're going to do it with this one right here, letter C. So we're not even going to bother doing these. What we are going to do is we're going to call these diamond problems. And in a diamond problem, we start off with a diamond. So let's draw a nice diamond. Okay, I think I've settled on this diamond. So in a diamond problem, what we do is we take this middle term right here, minus 7, and we put it down here. Then we take this last term, the plus 12, and we put it up here. And our job is to figure out there are two numbers here, a and b. And a times b is equal to 12. And a plus b is equal to negative 7. And once we figure out those two numbers, we've solved the diamond. So, what two numbers multiply to make 12? Well, the first ones that come to mind is 3 and 4. So let's try 3 times 4. So 3 times 4 is 12, that's right. But if I do 3 plus 4, I don't get negative 7, do I? But it's close, it's positive 7. So what I should probably do is just make that negative 3 and negative 4. So this kind of works because negative 3 multiplied by negative 4 is 12, and negative 3 plus negative 4 is negative 7. So we can, in our diamond problem, just go ahead and pop those numbers in, minus 3 and minus 4. And based on that, we have the solution to our problem. It is x minus 3 and x minus 4, just so that you can see where those numbers are coming from, yellow and the blue over here. So that is actually a super easy way to solve a lot of these problems. So let's try another diamond problem, letter D. All right. This time I've got the 7, so that goes at the bottom, it's positive, and then the 12, it's positive, it goes on top. Oh, and you know what? I just realized these are going to be the same numbers, aren't they? It's going to be plus 3 and plus 4. And by the way, it doesn't matter if you do it plus 3 and plus 4 or plus 4 and plus 3. It's the same thing. So x plus 4, x plus 3 is equal to x squared plus 7x plus 12. Of course, you can check your work by foiling. If you care to do that, you should get the same result, but I know that I'm going to, so I think I'm going to opt out of that. Let's keep on working here, and let's try to factor some of these in extra practice. So we're going to factor the polynomial. Start with number 1. That's always a good one to go to. Let's get a diamond there for number 1. Let's practice putting the numbers in. I know that 7, positive 7 goes up here. Positive 8 goes over here. So I need to think of two numbers that multiply to make 7 and add to make 8. Okay, and that is going to be, hello, hello, plus 1 and plus 7. So we've got x plus, oh no, it's not x, it's c. C plus 1 and c plus 7. Okay, that's how that works. Let's try another one. How about we go down over here with letter number 7? Or, ooh. Okay, so the last term here, the constant term, is negative 54. So I'm going to put a negative 54 here. And then this constant, the linear term, that's plus 3. So I'll put a plus 3 over here. And this is going to be a little bit more difficult because I need to think of two numbers that multiply to make 54 and add to make positive 3. Now, a little hint here. If you see the red square is negative, that means you're going to have one positive number and one negative number. So I'm just going to go put a positive here and a negative here. Okay. Now, I need to get to 54. So let's see, what are all the pairs of numbers that multiply to make 54? Well, that's 1 and 54. Okay, 2 times 27. You see, does 3 work? Yes. 3 times 18? Yeah. How about 4? Does 4 work? I don't think 4 works. 5 doesn't work. 6 times 9, yep, 6 times 9 is 54. And that is it. 7 times, no, this is it. So, one of these numbers is going to be positive, one of these numbers is going to be negative, and I need to get to 3. So let's see. 1 and 54, if I subtract them, okay, this is a subtract type problem, I get 53, and that doesn't work. 2 and 27, that gives me a 25. That's not going to work. 3 and 18, if I subtract, I'm going to get a 15. That's not going to work. And 6 and 9, if I subtract, I get, oh, look, that works. That gives me a 3. It just happened to be the very last one. So we're going to figure out, does it need to be positive 6 or positive 9? And by the fact that I have a plus 3 here, that should tell me it should be a plus 9 and a minus 3. All right, so my answer here is going to be B plus 9 and B minus 3. All right, that's pretty good. Let's try number 8 because 8 is a good looking one. We're going to put the numbers in. The first number we'll put in is this minus 2. And this says minus y here for the second number. So that's actually a minus 1. Okay. So this is, notice how it's a minus 2. So this is going to be a subtract type problem. We're going to subtract our two factors. So what are numbers that multiply to make 2? Actually, there's only one. It's 1 times 2. And if I do some subtraction, 1 minus 2, that's going to give me a 1, a negative 1. So actually, in my head, I would actually do 2 minus 1. So I'm going to do 2 minus 1 here. That gives me a 1. Okay. If it's a subtraction type problem, you subtract. If it's an addition type problem, you add. Pretty easy. Okay, so we got a 2 and a 1. One of them is going to be positive, one of them is going to be negative. And I think that needs to be a positive 1 and a negative 2 so that I can make the negative 1 in the white diamond. So y plus 1, y minus 2. These are going to take a lot of practice for us, aren't they? Let's try another one. How about number, let's do 11. Yeah, let's do 11. Okay, we're going to put our diamond in place. We'll put our numbers in place. I've got a negative 24, so we'll put a negative 24 right here. I've got a positive 2 in the linear term, so I'll put a positive 2 at the bottom. And then we're going to decide, is this an adding or a subtract type problem? And it's a negative 24, so we're going to be subtracting. So let's go ahead and do that. What are the factors of 24? 1 times 24. What about 2 times 12? What about 3 times 8? What about 4 times 6? And that's it. Let's do some subtracting. 24 and 1, that gives me a 23. 12 and 2, that gives me a 10. 8 and 3, that gives me a 5. 6 and 4, that gives me the 2 that I've been looking for. Okay, one of these has got to be positive, one of these has got to be negative because this is a subtract problem. So, I don't know. Which one needs to be positive, which one needs to be negative, so I get plus 2? Well, the 6 has got to be positive, and the 4 has got to be negative, giving me h plus 6 and h minus 4. Remember, negative 6 or 6 plus negative 4 has to be 2. Positive 6 plus negative 4, that has to be equal to positive 2. And then also positive 6 multiplied by negative 4 has to equal negative 24. That's why those two numbers work. So we're going to move on. Going to keep trying these out. Let's try a positive type problem. 13. Oh, look at 13. Let's try 13. We'll put our numbers in place. Positive 40 on top. Negative 13 on bottom. And then we notice that it's a plus type problem. So we're going to add our factors together. What are numbers that multiply to make 40? 1 times 40, and when we add them, I get 41, so that's not going to work. We've got 2 times 20, and when I add them, I get 22. That's not going to work. What about 4 times 10? And when I add those, I get 14. That's not going to work. Then, what's next? Oh, I know. 5 times 8. And when I add those, I get 13. So check mark on that. We needed to get to a 13. Okay. So 5 and 8, if I want to add them to make a negative 13, I'm going to need to make it a negative 5 and negative 8. Because negative 5 times negative 8 is equal to positive 40, and negative 5 plus negative 8 is equal to negative 13. And that's the way it needs to work. What's the answer? It's g minus 5 and g minus 8. All right. Okay, let's do some of these problems because these are kind of more difficult. Let's see which one of these. Yeah, 16 is going to be the one we're going to do. Now the problem with 16 is that it's not in standard form. It's got to be equal. There's got to be all together. There's an equal sign here, which is kind of annoying. So what we're going to do is we're going to subtract 30 from both sides. So let's subtract 30 from both sides, minus 30, and that gives us x squared minus x minus 30 equals 0. So now, again, we're ready for our diamond. Remember, it's got to be equal to 0 for our diamond. Let's put our numbers in place. I've got a negative 30 over here. So that means I need to put a negative 30 up there. I've got a minus x. So that means I should be putting a minus 1 here. What kind of problem is this? Is this a addition or a subtraction problem? Oh, it's a minus 30 up in the red square. So we're going to subtract. Okay. What are the numbers that multiply to make 30? 1 times 30. And if I do a subtraction problem there, I get 29. So that's incorrect. 2 times 15. Okay, and if I do a subtraction there, 15 minus 2 is 13. That's wrong. I'm looking for negative 1. I'm looking for 1, basically. 3 times 10, and if I do a subtraction there, I get 7. Incorrect. Oh, we're running out of options here, right? 4 doesn't work. 5, yeah, 5 works. 5 times 6 is 30. And when I subtract them, look at that, I get a 1. So it's definitely 5 and 6. Now the question is, one of them has to be positive and one of them has to be negative. So which one is positive and which one's negative? If you think it, you should be able to see that it's a negative 6. So let's do our check. Positive 5 multiplied by negative 6, that should be negative 30 in the red square. And then positive 5 plus negative 6. Why did I write a 6? Positive 5 plus negative 6, that should equal negative 1. And that is exactly what we get. So my answer, x plus 5, x minus 6 equals 0. And I don't think we need to do, no, we do need to solve this. Once we have this factored and equal to 0, we're supposed to solve. So in order to solve this, we're going to set each of these factors equal to 0 and solve. So the next step in this already really long problem is we say x plus 5 has to equal 0. And if x plus 5 equals 0, what's x going to be? And we've done so much, I'm not going to go through all of the long algebra. I just need to know that that's equal to 6. And then the other factor, x minus 6 equals 0. If x minus 6 is equal to 0, what is x? Well, that's positive 6. So those are our two answers, x equals negative 5 and x equals 6. So hopefully you guys are getting good with your diamond method, because it is the easier of the methods that we're going to look for. Okay, and this video is already about 25 minutes long, so we're going to have to cut it off here. I'm going to try and do another video with just a bunch of examples of diamond problems, so look out for that one, and I'll see you on the next video. Have a good one. Enjoy your factoring.